Good day. So in this video, we are getting the angular displacement. So getting angular displacement. Right, there are many ways to get angular displacement, which has a symbol of delta theta and an SI unit of radians. But um, we're gonna do the integral method. Okay, and this is the integral method. You can get the angular displacement of an object if you have the expression for its omega versus time, the function omega versus time, right? So maybe naka-get kag data, then naka-discover kag formula para sa omega versus time as a function of time man siya. So maybe, I don't know, 3t squared perhaps, and ma-plot nimo ang curve. Now, I'm sure you remember that the area under the curve of an omega time graph is the angular displacement. So, but in this particular case, we needed to do the integral because we needed a version of solving the problem because the curve is not a very trivial shape, doesn't create a trivial shape na dali ra ang formula sa area. Here we're basically just getting the area, but it's integral way of getting the area. It's a calculus way of getting the area. I'll leave the further explanations about integration to your calculus teacher. But just remember, this is just getting the area under the curve. Okay, right. Let's do some examples. A rotating object's angular velocity is found to be a function of time given by omega sub omega as a function of time is equal to 0.5 t squared plus 3, where t is in seconds and omega is in radians. Find the angle through which the object rotates between t equals 0 to t equals 5 seconds. The angle through which the object rotates, that's angular displacement. We now have an omega versus time graph for this particular function. I won't even try to draw that guy. I'm not sure how that looks. But there's always an equation grapher online to check. But let's see if I substitute t equals 0, 3 ang mabilin. So at t equals 0, the angular velocity daw kay 3. So nadira ang. Let's see if at t equals 1, the angular velocity is 3.5. So somewhere here. How about t equals 2? Bear with me, guys. It's 5. So 1, 2, 3, 4, 5. Maybe it opens up upwards. Okay, this is definitely a parabolic graph. Okay, na may squared. Something like that. So we're getting the displacement and yeah, basically we're getting the area, but we cannot use simple area formula because diba ang area sa delta omega versus time is the displacement. But we cannot use simple area formula, so we need to do a calculus version of the finding the area, and that is integral. Integral of omega t dt evaluated from time a to time b. And in this case, our omega t is 0.5 t squared plus 3. Conveniently so, butang lang nato dire. Evaluated from time 0 to time 5. So what are the rules of integration? We have this, I don't know the name of this rule, pero if you have x to the n dx, maybe it's a power rule power rule yapon, power rule for integration. Evaluated from a to b. The rule is, the integral is, or the area is, x to the n plus 1. So opposite siya sa derivatives, kaya katong sa derivatives minus 1 man, pero this case plus 1. And di ba sa derivatives kay ibutang ang coefficient ay ibutang ang power sa coefficient. This time we're putting the power sa denominator. So if, ang pasabot niya is evaluated from A to B. That actually means nga we substitute first B and then we subtract this time ang A na atong i-substitute. Alright. So there's another rule. Pag naay, what if naay siya ay constant nga gi-multiply? And if there's a constant inside the integral, pwede ra siya igawa sa integral. And this one you can do this again. So how about if you are getting the integral of a constant? Like 3. Okay, C. In general, C. Well, what happens is, mahimo siyang madugangan siya og x, or in our example, t. So, knowing those rules, this will become 0.5 t cubed, okay, 2 plus 1 over 3. And since this is a constant, may mo siyang 3t. Let's see. Sakto lagi. Evaluated from t equals 5 to t equals 0. Right. I didn't aturade. It's right here. Tabunan sa ako ang scribble. Evaluated from 5 to 0, we get the final answer of 35.83 radians. Okay. How about getting change in angular velocity? Okay. Now, if you have a graph for the angular acceleration versus time, the area under that graph is the change in angular velocity. And if the area is not easy to find, you have to use this area formula which involves the integral. Patiyo na siya sa previous, but lahi-lahi lang concepts. Let's see an example. A rotating object's angular velocity is found to be a function of time given by, well, acceleration as a function of time is equal to 3t squared. This is parabolic again, no? Where t is in seconds and omega in radians per second. Find the object's change in angular velocity from t equals 0 to t equals 5. So we want to know if pila ang change in angular velocity, delta omega. Let's graph this a little bit. At t equals 0, our angular acceleration is also 0. So this angular acceleration is not constant. It's a very complicated motion. Nag-change yung angular acceleration. As you said, omega is 3. For t equals 1, alpha di alpha. For t equals 2, 12. So it really grows very steeply. We're calculating the area under that. We can't use a simple area formula. We need the integral. Okay, wala na ako na. Spoiler alert. Spoiler alert. Right. So you can see here, ang 3 is a constant, so gigawas na ako siya sa integral. And this t squared, if you remember the rule, will become t cubed over 3, evaluated from 5 to 0. So, ang 3 ug ang 3 makancel, so basically it's just t3 t cubed, evaluated from 5 to 0 seconds, 0 to 5 seconds. So may mo siya 5 cubed minus 0 cubed, 125 radians per second. That's it. Thank you.